Question? Yes, go ahead. All right, so number one, we're asked to define the domain and range of this thing. What would be a good strategy to use here to find the domain and range of this particular function? Yeah, Julian's exactly right. Graph it, okay, graph it, okay? And we can use our graphing calculators to help us do that. So let's go ahead and type it in, right? So y equals, right, clear out anything you got there. And let's see, we need the square root of x minus 2 plus 5. So second square root, oops. Okay, oops, don't need the parentheses, plus 5. Okay, so just like that, I'll zoom out a little bit there so we can see that a little better. All right, and we'll graph it. All right, and we can see there the shape of our graph, right? So domain describes the x values, right? So what's the farthest left our x values go here, it looks like? 2. Yeah, 2. What's the farthest right we're going to go? To infinity. Yeah, exactly right. 2 to infinity. So let's see what we've got right here. So we can eliminate A and B we can eliminate right off the bat because they both have a negative 2 to infinity, so it can't be that one, and it can't be that one. So it's either C or D. Now let's look at our range. Okay, what's our lowest y value going to be here for this graph? What's the lowest y? 5. Okay, and so that gives it away then, right? Because the only one that has the lowest y value of 5 is D. It's got to be D. Okay. Now, you actually don't need your graphing calculator for this problem. Okay, you don't need it. You guys actually can figure this out mentally. All right. If you can remember what the shape of the square root function is, right? So the square root of x, the normal square root of x just looks like this. Oops, I'm off the screen. There we go. Normal square root function looks just like that. Okay? What kind of transformations do we see here in this function? What does that minus 2 do? Move to the right, how much? 2. Exactly right. And what is that plus 5 going to do? Go up 5. So hey, look, we started at 0, 0. We moved right 2. So our domain now is going to start at 2. Okay? And then we shifted up 5. So our range, which did start at 0, will now just shift up 5. And now it's going to start at 5. Okay? So you really don't need the graphing calculator there. You could do it mentally. But again, use the safety net if you need to. Right? It's there. But that one you actually can figure out pretty easily, just knowing from your transformations. Okay? All right, number 2. Choose the graph of the cube root of x plus 1 minus 4. Okay, so again, what's the obvious strategy to use here? Graph it in your graphing calculator and just match it up, right? But, again, look at your transformations there. Okay, now, the graph of the cube root of x looks like this. Okay, with that kind of center point going through 0, 0. What kind of transformations are we going to have according to what we have right here? Left 1, down 4. So imagine starting at 0, 0 and going left 1 and down 4. Is A our answer? No, it can't be, right? Try letter B. Left 1, down 4. Is B our answer? No, it can't be, right? All right, let's try D. Left 1, down 4. D is the answer because C does not have left 1, down 4. It doesn't have our center point there. It's got to be D. Okay? So again, your choice, graphing calculator, but you can also use your transformations if you just remember what the parent functions look like. Okay? Square root of x looks like that. Cube root of x looks like that. Okay? Those are the only parent functions you need to worry about. So I'm not going to have you worry about like what the fourth root looks like, although it looks very similar to the square root of x. I won't have you worry about what the fifth root looks like, although it looks very similar to the cube root of x. All right? But you don't need to worry about those. All right, number 3. Hey, transformations. We know those. Okay? What kind of transformations do we see here from the parent function? Now left 4, careful. Right 4. Up 3. What's that negative in front going to do? Reflection over the x-axis. So right 4, up 3. There's our right 4. There's our up 3. And then reflection over the x-axis. Be careful because they try and throw you off. They also say right 4, up 3, reflect over the y-axis. Don't use that one. It's D. It's D. Okay. And again, you can graph this and kind of see it too if you need to. You'd have to graph the parent function to help you too. Okay? So far, so good? Question? So, well, look at what the root is. It's a cube root, so you compare it to the cube root of x. Just the plain vanilla cube root of x. Yeah. Yeah, go ahead. Okay, number 4. And that's good, Braylon, from there? Okay. Number 4 then. All right, do we recognize this curve right here? What do you think the parent function for this curve is going to be? What's the parent function there? Is it square root of x or is it cube root of x? It's going to be a square root, right? A square root, because the cube root has like a whole, you know, wavy thing right here. This is a square root, right? It looks more like this, but it's transformed. Okay? Let's talk about how it's shifted. How is this graph shifted? Which directions? Left 3 and down 2. So which one of these, and a reflection too, very good. So which one of these is shifted left 3 and down 2? Yeah, A and C are both shifted left 3 and down 2, but which one is it? Yeah, it's C. Why? Yeah, this one's a cube root, right? We don't want cube roots, so you can see that if I zoom in there, right? It's a cube root. A is that's cube root. We need the square root. Okay? Now, other strategies you could use here, you could graph each one of these in your graphing calculator. Take turns, right? Guess and check. Graph each one of your graphing calculators, see which one matches to this. That's another option too. Okay, so you could still use your graphing calculator there if you really wanted to. Okay, so far, number 1, 2, and 4, you could pretty much do in your graphing calculator, sweat. Right? 3 would be a little bit tricky to do with your graphing calculator, so you would need to know that there. I mean, you could kind of do it, but it's helpful not to be able to do it with that. All right, so 1, 2, and 4, 3 out of the 4 questions right there, boom, you got a 75% just being able to use your graphing calculator correctly. All right, let's go to number 5. Okay, number 5. Should we use our graphing calculator for this one? Yes, yes, and you could really use 2 ways. What's one way we could use our graphing calculator here to solve this equation? What could we do? What's one of our strategies we have to solve an equation with a graphing calculator? Yeah. Graph both sides. Yeah, graph the left-hand side, graph the right-hand side, find the point of intersection. All right. Option 2 with our graphing calculators, since it's multiple choice, you can just guess and check your answers. Like literally just plug it in for x and see which one makes it true. That's what you got to do. Okay. Or we could solve it, right? And that's what I'm going to do here. So I'm going to solve this because, I'm the math teacher here and I'm trying to show you guys how to do math and not just type buttons. But, you can use that strategy. It's a valid strategy. Okay? So I'll rewrite it over here. We'll add 8 to both sides. Remember, we want to isolate the radical. So we want to get the radical by itself. So I'll add 8 to both sides. That cancels. I got the cube root of 5x minus 5 equals, and then that's going to be 5. Okay? And then what do we do at this point? Once we isolate the radical, now what should I do to both sides? I have a cube root, so I want to get rid of that by cubing. Okay? And so what does this left-hand side simplify to be? 5x minus 5. 5 to the third, 125. And then you guys can solve from here, right? Add 5 to both sides. Okay, 5x equals 130. Divide both sides by 5. X equals 26. Hey, there's our answer. Ooh, but we probably should check just to make sure it works, because there is a possibility that there's no solution, right? So this 26 may not work. Let me check it out here. So 5 times 26 is 130 minus 5 is 125. Cube root, remember to do the cube root, you're going to press the math button here. Okay, and when we press math button, you can see there's a cube root option there, number 4. The cube root of 125, okay, is 5. Negative 8 plus 5 is negative 3. So check, 26 works. 26 works. Okay? Questions so far on 1 through 5? All right, so now that's 5 questions. 5 questions, 4 of which a graphing calculator pretty much makes trivial. 4 out of 5. That's now an 80%, right? So if you just know how to use your graphing calculator correctly, you can get an 80% so far on this test, right? If you just completely forget about that question. But you can still do that one too. It's pretty easy, right? 80% so far, right? All right, let's try the next one. Hey, another equation. Okay, another equation. So now we're talking 5 out of 6. 5 out of 6 questions here we can solve using a graphing calculator. And the next one, another equation. 6 out of 7 of the questions right now, graphing calculator. And then number 8, another equation. 7 out of 8 of the questions so far. Graphing calculator, if you just know how to use your graphing calculator correctly, right? That's all there is to it. But again, I'm going to show you how to do it without the graphing calculator here. Okay, so square roots are isolated, so what should I do to both sides to kick off solving here? Square both sides, right? Just square both sides. This one's super nice because it just cancels them both out. We have 3x plus 12 equals x bless you plus 8. Subtract x from both sides. Okay, We get 2x plus 12 equals 8. Subtract 12 on both sides. We get 2x equals negative 4. Divide by 2 on both sides. We get x equals negative 2. Okay. Again, we want to be careful. We want to check this answer to make sure it makes sense in the problem. So you plug the negative 2 back in. 3 times negative 2 is negative 6. Plus 12 is 6. We have the square root of 6 over here. And then plug in negative 2. Negative 2 plus 8 is 6. Square root of 6 over here. Is the square root of 6 equal to the square root of 6? It is. So B is the answer. Okay. All right, number 7. I didn't leave myself very much space here. Let's see if I can do like something like this. Okay, so for this one, okay, again, you could graph it in your graphing calculator. That's option 1. Option 2, you could also guess and check these answers. That's going to be a little bit tricky here with letter A, right? Trying to guess and check that. But you could still use your graphing calculator here, get that x value, and then you'd have to check this one. You have to like type it in your calculator to check the decimal and match the decimals potentially. Okay, so we do want to be careful with that. But let's also just go ahead and solve it. Okay, so again, in this one, what should we do to both sides to start things off? Right, the radical is already isolated, so we'll just square both sides. Okay, this simplifies to x minus 1. This simplifies, well, we have to FOIL it out. Okay, this is like what we talked about earlier. We have to do x minus 7 times x minus 7. So if you'll permit me here, I'll just go ahead and just do it all at once. Okay, we get x minus 1 equals x squared minus 14x plus 49. And then we want to set it equal to 0, right? So what should I do with, yeah, we're going to subtract them over, make it equal to 0. So subtract x, add 1. Subtract x, add 1. And so we'll get 0 equals x squared minus 15x plus 50. And, ooh, it does factor. X minus 5, x minus 10. And so we'll get 5 and 10 as our two answers here. Okay, we got to check them, right? Plug them back in. So what's 5 minus 1? 4. Square root of 4, 2. But then 5 minus 7 is negative 2. So I get 2 equals negative 2, so I got to throw 5 out. 5 does not work. We'll try 10. 10 minus 1 is 3, or sorry, 10 minus 1 is 9. Square root of 9 is 3. 10 minus 7 is 3. 10 works. So it's just 10. Be careful. Do you see what they're trying to catch you on here? You see how they're trying to catch you? Letter C, they're going to try and trick you. They put both answers in there, okay? Because they're trying to catch those students that don't go back and check their final answers, okay? But remember, if you graph from the very start, you'll only have one point of intersection. So if you graph the left-hand side, graph the right-hand side, you'll only have one point of intersection where it works, okay? So D is the answer there. All right. Ooh, now this one right here, very interesting. Okay, x plus 3 to the 2/3 equals 4. So I'm going to do this one down here. Okay, x plus 3 to the 2/3. Okay, ideas here about how to tackle this one. Ideas here about how to tackle this one. This one's a little bit different. So there's kind of two different ways I can see you thinking about this. One, we can think about it just like we did with the two earlier ones here. Okay, well, actually, one more step back. We could graph this right and then find the point of intersection. That'll be our solutions there. But again, to solve here, I have 2/3 as my exponent there. Okay. What power is going to cancel out 2/3? What power will cancel out 2/3? Yeah, that's tricky, isn't it? What power will cancel out a 2/3 power? Okay. Well, let me tell you what it is. It's 3/2. It's 3/2. Okay. Why 3/2? Well, it's reciprocal. And what happens when you multiply reciprocals together? What do you get? When you multiply a number and it's reciprocal, what do you always end up with?
0.
Not 0. What's 1/2 times 2/1?
1.
It's 1. What's 1/3 times 3? What's 1/3 times 3? 1. What's 2/3 times 3/2? What's that? 1. Okay, so we multiply, we raised by the reciprocal power there, so we end up with just x plus 3 here, and then 4 to the 3/2. We can actually do this, guys. What does that 2 in the denominator really mean? We're going to do what? Square root it. What's the square root of 4? 2. And then we have to cube it then. So what's 2 cubed? 8. So the 4 to the 3/2, again, you could type that in your calculator if you wanted to, but we can do it in our heads. The square root of 4 is 2, then cubed. The square root of 4 is 2, and then cubed, it gives us 8. And then, wow, look at that. We just subtract 3 on both sides. We get x equals 5. Ooh, Mr. Wid. Since we square root, I got to do plus or minus, though, actually. I forgot that square root we're doing there, it's really going to be a plus or minus. So actually, I need to make this over here. We'll say x plus 3 equals plus or minus 8. And so we get x plus 3 equals 8, and x plus 3 equals negative 8 as well. And so then when I solve, I'll get x equals 5, and then subtract 3 from both sides here, we get x equals negative 11. Ooh. Okay, like that. And so we get this one. But I guess I need to check those too. So let's see here. 5 plus 3 is 8, cube root of 8 is 2, squared is 4, and negative 11 plus 3 is negative 8. Yep, they both work. Okay. So 5 and negative 11 are your answers there. Okay. But again, if that's uncomfortable for you, you're like, ooh, I'm afraid I'm not going to remember this. Well, you can always just graph. Right? Graph the left-hand side, graph the right-hand side. Find the x coordinates of the point of intersection. Okay. So again, graphing calculators there. Okay. Questions up to number 8 yet? Well, we're just reviewing. We have a quiz/test tomorrow. All right, let's go to the next one. Average rate of change. How do we find average rate? What is really average rate of change? It is the what? Average rate of change is the slope. Slope formula, exactly right. So we're just going to do the slope formula here. y2 minus y1 over x2 minus x1, right? Okay. Are we given any y coordinates here? Are we told any y coordinates here for number 9? Are we told any y coordinates? All right, let me ask another question. Are we told any x coordinates here? Yes. What are the x coordinates that we're given? We have negative 3 and 0, right? So I'll make this 0 minus negative 3. I'll put them in order. I'll call that x1. We'll call that x2. So I'll do 0 minus negative 3. But then what about the y coordinates? How can we find the y coordinates that match with these x coordinates? What can we do? I've got a function right here, don't I? And these points are going to be on the function. So what can I do with this negative 3 to get its matching y coordinate? Plug it in. So I'm going to go ahead and just write that as g of 0. Sorry, g of 0 first minus g of negative 3. Okay? So we're just going to plug 0 in here. Okay? 0 squared is 0, minus 0 is still 0, plus 1 is 1. The square root of 1 is 1. So I get 1. And then plug in negative 3. Negative 3 squared is 9. Minus negative 3 becomes plus 3, so it's 12. Plus 1 is 13, so it's the square root of 13, so minus the square root of 13. Okay? And then, well, plus positive 3 there for the denominator. So I have 1 minus root 13 all over 3. Hey, look, there it is. Letter B. Okay? Sorry, that's supposed to be like a separate problem right there. Okay, that one. So there's a second problem that you can't do straight up with a graphing calculator, right? So that's 2 out of 9. All right, so right now, if you're good with a calculator, right, you do 7 of these 9 problems with your graphing calculator. You're at a 77.7% right now, okay? As long as you get all those calculator ones right. But now we move on to some things that you can't use a graphing calculator for. So, number 10. No graphing calculator is going to help you with this one, right? You got to be able to simplify this by yourself. Okay. So we have the fourth root here. Fourth root, okay? Fourth root is the same thing as what exponent? what exponent is the same thing as the fourth root? 1 over 4, right? Yep. So we'll rewrite this as 16x to the 8th all over y to the 16th, and then that whole thing raised to the 1/4 power. Sorry, I'm off the screen. There we go. Okay, just like that. Now, what can I do with that 1/4 exponent? We will distribute it, right? So I'll have 16 to the 1/4, x to the 8th to the 1/4, and then y to the 16th to the 1/4, right? So the power gets distributed. 16 to the 1/4, you can type that in your calculator. Okay, what is the fourth root of 16? Or what times what times what times what gives us 16? 2. Okay, so we can eliminate C and D, or B right off the bat because they have 4s in them. We need the 2s. Okay, what about this? How can we simplify x to the 8th to the 1/4? What do we do with our exponents here? Multiply. What's 8? What's 1/4 times 8, or 8 times 1/4? It's 2. It's x squared. So we know the answer. What is it? This is 2. This is x squared. So it's got to be a. And then we can do the same thing here. 16 times 1/4 is 4, so we get y to the 4th. So that's another way to see that it's a there, right? You also get the y to the 4th in the denominator. Okay. Questions on that simplification there? So that one was nice, and again, we can kind of get clued in here, right? All of our answers simplified nicely, right? There was no more fourth root left over. So this one simplified really nicely, okay? If you look at number 11, right, this one does not simplify as nicely. When we simplify this, we're going to have some stuff left over, right? We're going to have some stuff left over, so we want to be careful with that, okay? So let's break this up. We'll make it the cube root of negative 16. I'll make it the cube root of a cubed, and I'll make it the cube root of b to the 8th. Okay? This is number 11 now. Now, cube root of negative 16. Is negative 16 a perfect cube? Is negative 16 a perfect cube? Are there 3 numbers that we can multiply together? 3 nice numbers that we can multiply together to give us negative 16? It's not, no. But we can divide it by a perfect cube. What perfect cube can we take out of negative 16? What perfect cube can we take out? What's that? Okay, so yeah, 8, right? Which then becomes 2. Yep, exactly right. Okay, so negative 16 is the cube root of 8, and I'll leave the negative, I guess I'll make it negative 8. Negative 8, and then the cube root of 2, right? Negative 16 is negative 8 times 2 there, so I'll make it negative 8. That is a negative 8 there. Okay, let's do this one. This one's easy. What's the cube root of a cubed? What does this simplify to be? A, yeah, it's an easy one, right? A. The cube root of b to the 8th, this one is also not a perfect cube, but we can break it down into b cubed times b cubed. That's 6, right? 3 and 3 makes 6, and then b squared. Okay, so again, I'm breaking down b to the 8th into a b cubed, another b cubed, and then b squared. Why am I breaking it down to the b cubes? Because we're taking cube roots. I need perfect cubes here. Okay, perfect cubes. So it's a b cubed, and a b squared, right? Those would combine back together and be b to the 8th. All right. Cube root of negative 8 is going to give me negative 2. Cube root of 2 is going to stay cube root of 2. A will stay A. Cube root of b cubed will give me a b. Then I have another b, because that b cubed, and then I'll have the cube root of b squared left over. I cannot cube root the b squared there. Okay? And so now I'm going to collect all the stuff that's outside the cube root, and I'll collect all the stuff that's inside the cube root. So I'll have a negative 2ab squared. Okay, negative 2ab squared. And then you have the cube root of 2 and the cube root of b squared. So we'll have the cube root of 2b squared. Okay, so negative 2ab squared is going to be b or c. Then we'll have 2b squared, cube root of 2b squared. So it's b is your answer here. Okay, 11 is b. Okay, questions on number 11? That's probably the trickiest one we've done, I think, right there. Okay, the trickiest one. Question on any of that? All right, number 12, simplify this expression right here. Okay, we're multiplying, right? So what gets multiplied together here for this expression? The 2 here multiplies with what else? The 2 here multiplies with what else in number 12? What else do we multiply that with? The 4 and the other 4, right? So 2 times 4 is 8, times another 4 is 32, so I get 32. Okay, and then we have these m's, right? Since we're multiplying, what do we do with our exponents? When we multiply, what do we do with our exponents? Add. So 2 plus 3 halves plus negative 2. Well, the 2 and the negative 2 will just cancel out, so we're just left with the 3 halves. So we'll have m to the 3 halves. Okay? So it's got to be d, right? There it is. That's just using your exponent properties. Okay? 13, inverses. This is like one of the first things we talked about in this unit, right? So we're going to change this to y equals negative 1/64, x to the third. Okay? And then what do we do with our x's and y's? To get an inverse, I changed f of x to y, and now what should I do with my x and my y here? We need to what? Swap them, right? Swap them. So I'll make this then x equals negative 1/64 y to the third, and then you just solve for y. You just solve for y. So we'll multiply both sides by negative 64 to get rid of the fraction. Okay, and so we have y cubed equals negative 64x. Okay, and then to get the y by itself, what's our last thing we got to get rid of there? Yeah, we'll cube root both sides. Okay, so you get y equals, the cube root of negative 64 is negative 4, and then the cube root of x, so I can't do that, so I'll just leave it at the cube root of x. Okay, and so the answer is C. Negative 4 cube root x. Okay. All right, and then for 14, and this will finish off the multiple choice. For 14, which expression has the greatest value? You can literally type this in your calculator. Literally. Just see which one gives the bigger number. Okay, that's one way to do it. You could also simplify these. Okay, but I think the best way to do this will just be to type into your calculator and see which one gives you the best, highest answer. Okay, I'm going to see here if I can figure that out real quick. All right, 5 to the 3 halves. Cube root of 81, that's, and then cube root 2 to the 8. Okay, so B is your answer there. Okay, so what I'm going to do is I will finish up this video during my planning. I will cover these inverse questions. I will then also cover this one, and I will cover this one as well in the video. Okay, so check that out tonight if you want some extra help on those. Anyone want to come in for set today? I already have Nick requested. Anybody else for set today? Okay, remember, I won't be here tomorrow. I won't be here tomorrow to help you, so this is going to be it. So, Julian, you want to come in? Any other set requests? All right, please study tonight then, guys. Please study. Please study. Okay? Yep. And I'll continue this video here in just a little bit. All right, so we're going to go quickly over the remaining sections of this review. Okay, I already created a video. I'm going to splice the two together, so it should just jump right into this section right now. Anyway, so inverses. All right, now I am not going to find the inverse of every single function here. Well, maybe I will, but I'll go quicker through some of these. Okay, the basic idea for finding an inverse is to change f of x to y. Okay, like so, and then just swap x and y. Okay, and then solve for y. So get the y by itself. So in other words, here that would involve subtracting 4. I'm going to run out of space, so I'll move it up here. and then dividing everything by negative 5. And so we get y equals, excuse me, x over negative 5 plus, because negative 4 divided by negative 5 will be positive, and then positive 4/5 there. Okay? You can write it a couple other ways. You could also say y equals x minus 4 all over negative 5, like that. You could also make this x over negative 5. You could also make it y equals negative 1/5 x plus 4/5, like that. But any one of these would then be your inverses. Okay, technically we should also rewrite the y as f inverse of x then. Okay, from there. But they're your answers. Okay. Same thing here for letter B. I can make it y equals 2x to the third minus 2. Swap the x and y. Add the 2 over. Divide both sides by 2. Okay, and then cube root to get the y by itself there. Okay, just like that. And there's your answer, the inverse. Okay, same thing here. Swap the x and y. Solve for y. Now here we would not add 2 first, right? We have to get rid of the square. So we're going to square root both sides first. And then we'll just add the 2 over, and so we get y equals root x plus 2. Okay, and then for D, j of x there, again, y equals, swap the x and y, solve for y. So here we'll subtract the 6 over. Now we have to square both sides. Okay. You can FOIL this out if you want to, like x minus 6 quantity squared, or you can leave it unfoiled, your choice. I find it easier to just leave it like that, and we'll just add the 2 over. So in other words, we get f inverse of x, or it's really j, I guess, because we're talking about j inverse of x equals x minus 6 squared plus 2. And there are your inverses. Okay. All right, number 16. The owner of a health food store determines that the demand equation for selling a nutritional supplement is P equals 18 minus 1/2 square root of x minus 4. P is the price in dollars. X is the number of bottles demanded per week. Okay? So basically it's like the price of the bottles are going to change depending on how many bottles people want, right? So we're supposed to solve the equation for x here first. Okay, so we'll have P equals 18 minus 1/2 square root x minus 4. So we'll start by subtracting the 18 over. Then we're going to get rid of that negative 1/2. So I'm going to multiply both sides by negative 2, right? I could divide both sides by negative 1/2 if I wanted to, but dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm just going to multiply both sides by negative 2. So I get negative 2p plus 36 when I multiply by negative 2 over here. And then this is just root x minus 4. Okay. Now I'm going to square both sides to get rid of that square root. And again, I'm not going to FOIL this out. I'm just going to leave it unfoiled. And let's see if I can get away with that here. So negative 2p plus 36 squared, and then add the 4 over. And there it is, solved for x. Again, you could expand out that negative 2p plus 36, but let's see if we can get away without doing it. Okay. Letter B says if 523 bottles, okay, remember bottles, okay, that's the number of x bottles, right, are demanded 1 week, what is the price? Round to the nearest cent. So since we're going to do 523, we're plugging 523 in for x here, I recommend not using this version of the formula that we found. I recommend using this version of the formula right up here. So just plug the 523 right in there for x to find the p price, right? That's p we're trying to find. So it'll be 18 minus 1/2 square root of 523 minus 4. And now you can type that whole mess in your calculator if you want to. Okay. And that's what I'll do. I'll just show it to you right here. Let's see if I can get it to show up. All right, it's pretty good. So 18 minus 1/2, I'll just make that 0.5 square root of x minus, oh, not x, sorry, 523 minus 4. Okay? So about, it says round to the nearest cent, so about $6.61. Okay? And then for letter C, it says if the price now, so that's a P, if the price is $3.50, how many bottles are demanded that week? So in this case, since we're given a P, we're going to plug $3.50 in for P and then figure out how many bottles are demanded. That's going to be our X. We're solving for X. I'm going to use this formula right here, this version of it. So we'll say X equals -2 times $3.50 plus 36 squared plus 4. And again, just type that whole mess in your calculator. $845 bottles is what we would expect. Okay, easy peasy. Last question, we're going to do some graphing. Andy and Corinne are hiking up Mount Mitchell in North Carolina, which peaks, has a highest point, right, of 1.26 miles, or 6,684 feet, sorry, okay? The distance they can see on a clear day is estimated by the formula V of A, V for viewing, I guess, view, of A equal, and A is for altitude, 1.225 square root of A, where A represents the number of miles they are from the base of the mountain, altitude, right, and V represents the distance in miles they can see clearly. Okay, so to graph this, right, I'm going to put that here. Now I'm going to put that in my graphing calculator first to get an idea of like what scale I'm going to need to use here. Okay. I can see that I don't have any shifts left, right, up, or down, and so I can probably assume we're going to start at 0, 0 there, right? Because we're not shifting left or right, up or down, and it's a square root that we're graphing. Okay, but let's go ahead and put this in my graphing calculator. Okay, and then I'll go to the table and just get some idea here of the y values. It looks like I'll be able to count by ones here pretty safely, I think. Okay. So we'll go ahead and just use 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. And we'll say, wow, okay, this is number of miles. So altitude miles. Okay, now really we're not going to go up to 8 miles, but you know, you get the idea at least. And then for V, okay, that's going to be our viewing distance, the distance of miles that we can see clearly. So distance we can see, and this is again in miles. Okay, now it looks here again that I'm going to be not too shabby here. I might even count by like 0.5s. So I'll say like there's 1, and there's 2, and there's 3, and there's 4, like that. Okay, so I'm going to count every other one as 1 there. And now I'll just plot some points. So we have the point 0, 0. Then we have the point 1, comma 1.225. So there's 1, there's 1.5, so 1.225 will be like right in here. All right, let's go to 2. 2 is like 1.7, so 2, here's 1.5. 1.75 would be right here, so 1.73 would be like right there. Okay, 3 is 2.12, so 2.12, something like that. Okay, 4 is 2.45, so there's 2.5, 2.45 would be like right there. Okay, 5 is 2.73. Again, I'm getting these from the table on my graphing calculator. Table on the graphing calculator. 2.73 would be like right here. 6 is 3.00. Wow, that's pretty darn close. Okay, you get the idea. That's enough points, I think. We'll just kind of go ahead and connect the dots there. Okay, you can see that square root shape taking form now. Okay, so if Andy's altitude is 0.3 miles, how far away can she see clearly? Okay, so her altitude's 0.3. That means her A is 0.3. So we'll just do V of 0.3, and we'll just plug it back in the graphing calculator there. So it'll be 1.2, or plug in the equation, I should say. So put 0.3 in for the A, and you just simplify that. So in our graphing calculator, we'll type in 1.225 times the square root of 0.3. I get about 0.671. It says round to the nearest hundredth, so we'll say 0.67 miles is the visibility. Okay. Letter C, if Andy can see 1.25 miles away, what is her altitude? So again, we're going to solve for A, and we have V, which is 1.25 there. Okay? So I'm going to plug 1.2, I'm going to set my function equal to 1.25. And we'll solve for A. So we'll divide both sides by 1.225. Okay, I'm going to run out of space, so I'll go this way. Oof. Okay, I'm going to leave this as a fraction. And then I'll square both sides here. And I get A is approximately 1.04. Okay, so for the viewing distance of 1.25 miles, she will have to be at an altitude of 1.04 miles into the air, right? Okay. Describe an appropriate domain and range for this function. Okay, well, the domain here, right, our x values, those are describing the altitude, like the height of a person. All right, now, an appropriate domain, well, this is going to get a little bit tricky, right, because, like, well, obviously, the lower part of the domain's got to be no lower than 0, right? We're not going to be really trying to view stuff from anything lower than below altitude. I mean, there are places, right, like Death Valley, right, is below 0 feet. It's like negative altitude there, below sea level and stuff. But as far as, like, regular kind of altitude, I think 0 is a safe place to start for the lowest domain value here. Same thing for the range as well. 0 as well. Again, seeing less than 0 distance, that's like, that really makes no sense, right? Now, as far as the upper limit for the domain, this is where it gets tricky, all right? Technically, right, I mean, guess we could just keep going up and up and up and up and up, but the problem is eventually we're going to, like, leave the Earth if we just keep going up and up and up and up and up there. So, I mean, this is where, realistically, I think it's safe to, maybe say, like, I don't know. There is a limit. I mean, if you want to say infinity, you really could there. I'm going to say something like 10. Again, this is kind of just like a guesstimate there. For the range, for the distance of altitude we can see, again, or the distance we can see for the range there, again, hard to say, hard to say. So, you could say infinity, but that doesn't really make sense in the context here. So, I don't know. I'm not sure. I don't know. I'll say, well, if I put in that 10, okay, I get like 3.9 miles. All right, but again, I'm a little more lenient on the upper end there, but definitely for the lower. If you want to put infinity for the upper ends there, that's okay. But for the lower end, definitely 0. Right, definitely 0 for both ones. Okay. For letter E, it says the girls have already hiked to an altitude of 0.75 miles. They are tired, but they are considering hiking another 0.25 miles in altitude for a better view. What is the average rate of change of visibility over this change in altitude? Okay, so we have an altitude there, 0.75. We have another altitude. We're going to go 0.25 higher. So that means if we start at 0.75 and we add 0.25, we're going to be up to 1. So the two x coordinates will be 0.75 and then 1. Okay, so again, altitude of 0.75 and then 0.25 miles higher will be at 1. Okay, and so we got to find their matching y values. How do we find the matching y values? Use that function, okay, from up here. So we're just going to plug in 0.75 for A and simplify, and then 1 for A and simplify. Well, 1 in for A into simplifying is going to be easy to do 1.225. 0.75, if I plug that in for A, okay, so it looks like this. 1.06, we'll say. And you're just going to find the slope between these 2 points. So we'll do 1.06 minus 1.225. Okay, I get negative 0.615, or 165, I mean, over negative 0.25. Okay, so the top is negative 1.165, the bottom is negative 0.25, and then we'll divide them. And I get 0.66. Okay, and that's in units, like for the units here, it's going to be like distance of visibility per mile of altitude. So in other words, in this case, they're going to, at the average rate of change between these two, points at 0.75 miles in the air and 1 mile in the air, the average rate of change is 0.66 over 1, where they will improve their visibility by 0.66 miles every 1 mile they go up. Okay, so that's the meaning of it in this context with the units. All right, that's it. Good luck on the test on Wednesday, on tomorrow, okay, for some of you. And, I'll see you guys on Thursday.